Let me switch to this screen. I was looking at the monitor over here. We got a bunch of people already in the room, and I was chatting with them, and my timer went down to 0, and I didn't even notice. I'm Tim Van Milligan, and this is RockSim Live, where we talk about the RockSim software. This is where you can ask your questions about RockSim, RockSim Pro, or the Launch Visualizer, and I will try to answer them and do the best job that I can. So if you have a question, go ahead and type it in now. Get your questions in early. I have no agenda today. I am totally focused on answering your questions, so this is unscripted. We've got several people saying hello. Mark Gillette from Orlando. Carlos, he's from Georgia. We have Johan from the Netherlands, and it's 10 p.m. there, so he is past my bedtime there. We have Alfred Indy. I don't know where Alfred Indy is from. And then we have Vlatko from Bosnia and Herzegovina. So yeah, it's probably really late there too. Carlos says my audio is repeating. Is it kind of echoing? I don't know why that would be. Alfred Indy says love your display rocket. So this is an AMRAAM, and who's this from? We got so many rockets. I'll think of Rocketarium AMRAAM. So I just every week I go out to our front display, which is over that way, and I look for a rocket to display and show off. And usually I pick an Apogee or a Dynastar. And today I grabbed this Rocketarium because, I don't know, it was something different. We've got the first question already came in. Alfred Indy says he's from Saginaw, Michigan. Let me go to my website and give you the introduction. So if you got a question, go ahead and type it in so that I can answer it. So here is RockSim, but we want to show the website first. So I want to go to the Apogee website. So if you're watching this for the very, very first time, you're wondering what RockSim is and where I can get it and where I can get help. So I'll cover that real quick. So RockSim is our software for designing rockets. We have also the Launch Visualizer, which is a subset of RockSim, but it's online. It's in the cloud, so you don't have to download anything. You can just go to the website and start launching rockets. And the Launch Visualizer is at rocksim.com. And here's RockSim. So if you click on this banner ad on the Apogee website, it will take you to the RockSim page. And you can download a free trial version right up here. You can order it here. Here's upgrade instructions. If you have version 8, version 9, you get a free upgrade to version 10. And we've been doing this now for almost 2 years, giving that free upgrade for all of our version 9 users. Version 8 and below, so version 1 to version 8, there is an upgrade fee. But from version 9 to version 10, there's not. Because version 8 it's been about 12 years ago. So there's a lot that has changed, and it's getting better and better. So if you want to learn how to use it, go to How To and Guides, and come down here to Software, click on that, and then come over here. On this side is all the help. And then here is more information about RockSim, like the free trial version you can download, purchasing it, a generic overview of what it is, the frequently asked questions, stuff for teachers, the system requirements, the version history, what's changing. And then here's where, if you're wanting to learn it from the start, I would start here with the video tutorials. That would be like the really good place to start, because that'll walk you through from the very first time you open it right up until you're running simulations and loading your own motors and doing really complex things. There's also, this is a common one, loading missing motors back into RockSim. We're working on fixing that. RockSim Live Training, RS Live, stands for RockSim Live. And let me quit these things, or things are going to be popping up on me. Quit. So RockSim Live Training is what we're doing right now, and we archive all the previous episodes, and if you click on that, it'll take you to the archives. So last week was April 8th, right here, and these were the topics that we talked about: how to select rocket motors. You know, this is like the basic stuff, you know, like the stuff that you really need to know. Because with RockSim, you can, as we demonstrated last time, with 3 clicks, you can get hundreds of rocket motors that would fit your particular design. We did nesting fins with inside other fins, and we covered ejection charges and how to calculate ejection charges. So that was last time. That was episode 64. We're on episode 65 today. Something that's new. Last week I talked about we're working on a new version. I thought it would be done by last Monday, and it's not. They had some difficulties, and they found more bug, and some things reverted back to old bugs, so they have to fix those. But I did upload what the changes are, what the big changes are. So that's under version history. So version history is right there. And if you scroll down, and what's coming is right here, version 10.4. Right now we're on 10.3.1. Our current one is right here, 10.3.1 F4, and we're going to be releasing 10.4.0. So whenever we go up from this tenths digit place right here, the 3 to a 4, that means new features have been added. And this last one here would be new bug fix, if anything was bug fixed. So we went in version 10.3.1. What we changed was just bug fixes from version 10.3.0. So that's what those numbers mean. So this has new features, and these are the new features that are coming. And then we fixed a whole bunch of bugs, probably 12 or 13 different bugs. There was a bunch of crash ones. And so those are the ones that everybody prays that we fix. And yes, we are aware. And we've been, so there was one particularly nasty bug that happened only on occasion, and it's just random. And that's the hardest kind of bug to fix, when they just kind of out of the blue, and you can't repeat. If you can't repeat a bug, it's so a dialog box. And if you document it and document everything you did and gave us all your system information, you know, like I'm running Windows 11 or Macintosh, you know, 10.12 or 10.13, that kind of information, not your private information, just specific information about your computer so that we can try to duplicate it and fix it. And if you give us all of that, then we're going to give you a credit for merchandise at Apogee of I think I'm going to go $10. So I'm putting my money where my mouth is, that we are serious about fixing these things so that you have a good experience. Okay, so that's the basics about rockets, RockSim, what's on the website. So let's go to the questions. And we had the first question from Julia Kaufman. Julie, not Julia, Julie Kaufman, she says, Apogee going to develop an L3 CERT power rocket. The immediate, no, but long term, maybe. We got so many things that are going on, and I do want to do more high power kits. That is on my near term horizon, not the immediate, but near term. It's a logistical challenge because we need components that we don't currently have. So we've got to source components, bring them in, design the rocket, get everything done before we can release a rocket. It's a challenge. And I am currently looking for a product developer to do some of this work for me. So if you know somebody that's looking for a job here in Colorado Springs that wants to design rockets and source components and do quality assurance to make sure that everything that comes in is good quality, that's the kind of person that I'm looking for. We got a lot of positions open, like every other company in the country. We got production people, we've got office people that we need to hire, computer programmers. Just to keep everything running and growing, we're hiring. And so, yeah. And speaking of which, one of the things that I want to try, and this might involve you, is I would like to see if somebody would like to guest host this RockSim Live, kind of like on a Zoom. So basically I would turn over the presentation to you, wherever you are in the world, via Zoom. And because what I want to see is how you, as a real user, use the software. So basically you don't have to, answer everybody's questions, the really hard ones. But I just want to, go through designing a rocket, how you design a rocket. I think that would be really cool to see, just not how I do it, but how you do it. For me, it's feedback, it's customer feedback. So if you are interested in that, don't use the chat, just send me an email through our contact form. Our contact form is on any page of our website. So if you're on our website, it says talk to a real person, and then right here, says contact form. Just click on that and that will bring up our contact form where you can send us a message, and where it says send email to, just click on that and you can say RockSim general questions and support right there. And I see those, so I would be the one reading it. So hopefully, Julie, that answers your question. Carlos K says, how about 1-inch forward pointing cove fins on small balsa stubs? Carlos, I'm not sure what that question is. Cone fins. How about 1-inch forward pointing cone fins on small balsa stubs? I'm not sure what that means. I gotta quit all this stuff because everybody's popping up here with stuff. Quit. I'm looking at the chat over here. Pillow, which is Stephen Brancato. Pillow from Bishop, California. Just recently bought a laptop. The other one crashed on me, so pretty soon start up a RockSim. Okay, so Stephen, what you can do, I wonder if I can do this without revealing too much information, but when you log into your account, go to the Apogee website, because Stephen, what you're going to need is your unlock code for RockSim and from anybody that's using version 10, we have them stored on the Apogee website. So you go to the Apogee website, you log in, you know, you're going to use your whatever login you used when you bought anything from Apogee. You sign in, and then you go back to my account, and then it will list your RockSim unlock codes. So that's where you will find them. That's the easy. That way we're out of the loop, and you can do it like right away. So that's a good tip to know. All right, so 1-inch cone fins. So one of the things that's fixed, that should be fixed. Let me see if it's in this one. So let me open a design. RockSim designs. Doesn't matter which one. Let's go with airmail. Okay, so here's a rocket, and we're going to add pods because he wants a cone fin pointing forward. Let's add a pod. So a pod is anything on the outside. Because if you look at the fins as the components, there's, you know, we have fins, custom fins, ringtails, and tube fins, but there's nothing that says cone fin. So in order to kind of cheat the system of RockSim to get around this thing, sometimes you can put a pod on the outside and then attach components to that could do what you want. And so we want a cone. Well, maybe we can use a nose cone on the outside. So we're going to start with adding a pod, and first I need to know where I'm going to attach the pod. And I'm going to attach the pod to the body tube here. This tube, and I just opened it. I just wanted to highlight it. So it's highlighted, and you can see it right here. And we're going to attach a pod. So I'm going to come over here to pod, click on that. And this is our pod. I'm not going to name it right now, but right now I just want to see where it's attached. So if I go to a side view, here is where it is going to be attached. And we can move that location just by dragging this slider bar right here, and you can see that it moved. I'll leave it right there. Let's see what happens. And click OK. Okay, so now we have under here somewhere should be a pod. So there's the pod, and we're going to add a nose cone. Okay, and what it's doing is looking in the database, and I'm going to choose something like a BT50 size, which is 24 millimeter. So here's a 24 millimeter. That's a 24 millimeter. Let's choose that one. Click OK, and it drew it right there. So now we have a cone. Let's take that cone. What you want to see is, does that cone affect the stability of the rocket? And to figure that out, we need to look at the center of pressure right here, because the center of pressure affects the aerodynamic center, or the center of pressure, or the nose cone. And if we change the location of that, and if the center of pressure moves, that tells us that the nose cone is affecting it. It's kind of acting like a fin. So I can't move it here, but I can move the pod. So I'm going to click OK here. Oh, look, it's got a texture on it. I was playing with textures. This is one of the bugs that the programmers are still trying to fix. Is the texture got flipped, and you can tell by looking at this one here. The E, it says United States, but the E and the S are backwards, so they got flipped. And yeah, so they need to fix that. But anyway, so let's take that pod, and if we move this pod and this moves, that would be a good sign. And sure enough, it is moving. It's not moving a lot. The reason why is because these fins they create so much force on the rocket compared to a nose cone that they kind of overpower the nose cone's contribution. So let's do this. Let's go back to that nose cone. Oops, this nose cone here. Edit the nose cone, and I'm going to take the texture off because it's confusing me. So I'm going to just delete this right here. And let's also get rid of that shoulder right there. So let's go to the shoulder and clear that. So to clear it, I just take away the dimensions. You can see that, yep, that shoulder just went away. So now we just have a conical part. And we can make it a cone if we want, just coming up here to the shape, choosing conical, and now it's a conical. I don't know if you noticed that when we changed it from a ogive to a conical, that the center of pressure shifted rearward. So if I go back to ogive, it should shift forward. So just watch, it's very subtle. It just shifted just a little bit. Let's do that again. So I'm going to go to a cone shape, and yeah, you see it just moved back just a little bit. That tells us that the center of pressure on a cone is further to the rear than the center of pressure on an ogive, which is interesting. That makes sense, but I just never thought about it before. Click OK. Let's get rid of these fins. So I'm going to delete all the fins because I want to add, now I want to add more of the nose cones and see if I can make a stable rocket with just nose cones as fins. What did I do? Oh man, I don't have an undo. I deleted the wrong thing. I deleted the tube. Oh, I do have an undo. The undo doesn't do anything. That's one of the failures of RockSim. It does that. It has no undo. Let's do that one. Save changes, no. Open recent error mail. Let me see if I can recreate that really quick. Well, first let me delete these fins. Delete, yes. Delete, yes. See what happens is it keeps going back up there to the sustainer, and that's why. Yes. Delete. Yes. Okay, so now we're going to add the cone. If you have any questions, we're almost done with this question. So if you have any more questions, go ahead and type them in, and I will try to answer them for you. So we're going to add the pod, and let's see it in 2D to see where that pod is. It's right there. We slide it back. And yeah, let's leave it right there. Click OK. So right now, if you look at it in 2D, it tells us the rocket is unstable. The center pressure is way up here, and the center of gravity is here. For a rocket to be stable, the center of pressure has to be behind the center of gravity. Let's add a nose cone to the pod. Where did my nose cone go? 24. And we'll delete the shoulder. Again, just delete it by taking away the dimensions. Hit tab. Okay, so why did that nose cone delete? Database, the shoulder, my shoulder, clear shoulder value. Okay, there they go. All right, so now we got that center pressure to move. It was up here. We got it to move to here, but we need to move it further back. So we need more stability back here. So to do that, right now we only got one, so let's duplicate that. So I'm going to highlight the pod and do a copy, and then come up here to the body tube and do a paste. So to bring up that little menu, I just right clicked with my mouse and just paste. So now there's another pod right here, but it's right on top of this one. So I need to switch that one around to a different position on the rocket. So let's look at it from the back view. Right there's the pod, and we're going to change the radial position. We're moving it, what am I going to do, 120 degrees. Let's see if 3 of them will work. And let's go to a side view. Yep, it's going to work, because already with 2, I'm already stable, but it's marginal. So let's add the 3rd one. So again, to do the same thing, we're going to do a copy and paste, but it's already on the clipboard. So I'm just going to go to the body tube and do a paste. And so here's the 3rd one. So now we got 1, 2, 3. Again, that 3rd one is in the same location as the first one, so we need to move it. So I'm going to open it, change the radial position. Let's go to minus 120 degrees. Hit tab, and you can see it shifted around, and now it's down here. If we look at it from the base view, we should see 3 tubes, or 3 nose cones. This is kind of a funky looking rocket. Click OK. Let's go with 3D view. Click off the rocket. You can see they're hanging off the side of the rocket like that. It would be kind of hard to mount, but theoretically this is a stable rocket. It's probably not really stable. You know, I think with the regular fins, the CP was way back here, and so it's less stable. But you could try it. RockSim says it's worth a try. If you angle those nose cones in RockSim, everything has to be oriented parallel to the longitudinal axis of the rocket. So I can't angle these nose cones. I can't flip them to the side like you would see on a Soyuz. Let me bring up a Soyuz or a Vostok. Soyuz. So you can see that these are cones from where the orange and the green separate. From there to there, it's like a nose cone, but they're tilted towards the body tube, so that this axis here is parallel to that tube there. Unfortunately, you can't do that in RockSim. It would break the equations, and we don't have new equations to put in there to make it work. But yeah, that'd be cool to fly. No more questions. Come on. This is your chance. I'm here to answer questions. Well, let's fly this rocket then. Carlos says paper cone material. So if you want to make your cones out of paper, go to the nose cone and you just select the material. So right now the material is polystyrene. You just come down here to paper. And you have to tell the thickness of the paper. Typically 0.03 is fairly thick. That's like thick cardboard fins. So it'd probably be, 0.01 instead of 0.03. 0.01 if you have like an index card, that's at like about 0.01 inches. Let's fly this rocket. So I'm going to put a rocket motor in it. So to do that, go up here to prepare for launch. And it says it's got an 18 millimeter motor mount tube. I'm going to choose an engine. This rocket's on the hairy edge of stability, and when I'm looking to see if a rocket's going to start tumbling, I like to use a long burn motor. So I'll come here to the burn time, and you can sort this list by just clicking on it. Right now it's sorted from the fastest burning to the slowest. So the slowest burning will be down here at the bottom. And it's an Aerotech D2.3T. That's a reload motor designed for remote RC airplanes. So it's really long burn, very low thrust. You can see the average thrust here is 2.114 newtons, where compared to an Estes A3, this is 2.6. So it's just like barely bigger than an A3, but it burns for 8 seconds. So I'm going to load that motor into the rocket, and we'll change it to a custom delay, and we need to select a delay. We'll make it a short delay because I have a feeling that this rocket's going, as soon as it burns out, it's going to be going so slow that you're not going to need a long delay. Click OK. I'm just looking at the flight events, deploy the parachute at maximum ejection delay, which will be that 3 seconds that I just selected. Starting state, we got a 36-inch launch rod, and it's 6.5 degrees from vertical and kind of pointing to the northwest. North is straight up. This is like a compass, and so that's the way it's pointing. And launch conditions, 148 feet above sea level. Latitude is 44.59. Longitude 11.65. So this might be in Europe somewhere. Let's see what that looks like in a flight profile. So it's loading the maps right now. There's my rocket sitting on the launch pad. Let's make this a little bit bigger so you can see it. Let me zoom out, kind of get a perspective on where we're launching from. This is in Italy. You can see the boot of Italy, and the rocket launch pad is somewhere right there. So let me zoom back in. This is there's a rocket club there in Italy, and this is the site they use, except I'm not exactly sure where they launch from. They've got, it looks like a very short RC airplane runway right there. This like right here looks like a full-size airplane, and this long strip of grass is probably a runway for like a glider, like an aero sport, maybe parachuting as well in this area. Very nice field. It doesn't look like there's any trees around there at all. There's some trees way over here and maybe some trees right there. So let's, oops, I'm making you get vertigo there. Sorry about that. So right now I'm launching from right there, and let's launch, and the rocket's taking off. It's mostly stable, I would say, but it's really weathercocking. Oh, I zoomed out too far. Okay, so now the parachute opened and the rocket is coming down. So north is kind of towards the top of the screen, south is down here, and it's kind of drifting to the east. So that means we've got a wind coming out of the west. And where are we going to land? So I can just take the time slider here and slide it forward. Oh, it's kind of going towards those trees that I didn't want, but I think it missed. Landed here in this field. Crossed a little pond, missed that. That's nice. These trees look very uniform, so that must be some kind of grove of some kind. That's not a terrible launch. Let's see if it weathercocked too much. We can look at that to see where the apogee point is in relationship to the weathercocking cone. So let me turn on the weathercocking cone and it will draw a cone. And you can see the cone right here. It's kind of faint, but we want the apogee point, this point right here, which is the highest point, to be inside of that cone. So this is weathercocked too much, and with a long burn motor I would kind of expect that to happen. The rocket is it's coming off very slow. Let's get another view of that. Let me zoom out just a little bit. That's it sitting on the ground. Let me put it right back on the pad. Let me turn off the weathercocking cone. And there's the rocket. It takes off. This is a close-up view. This is a far-away view. And I'll zoom out just a little bit so we can see more of the trajectory. And there's Apogee. Yeah, so yeah, it's cool. You know, I like that flight, other than the weathercock too much. Okay, so either my chat has stopped working or nobody's got any questions today. Julie says she's from Northeast Indiana, which is very nice. I've got relatives in Indiana. Okay, come on, give me some questions. I don't know if that answered your question, Carlos, about a very short 1-inch forward pointing cone fins on small balsa stubs. One of the bugs that we fixed was when you put tube fins on pods. So let me go to these nose cones here. Let's add a body tube to that. So we need a 24 millimeter diameter, and this is going to be 6 inches long. And let me go to side view. So there is the rocket. And if I add a tube fin to that body tube, before there was a bug, and we think we fixed it. So let's choose a tube. We'll go 24 millimeter diameter, and we'll make it 1 inch long. So there's the tube fins right there. I need to make this bigger so you can see it. So to make this screen bigger, you just move your cursor up and down until the cursor changes to that, and then you can click and drag, and you can make that screen bigger so you can see what's going on. The bug before was if you put tube fins on a pod, it would actually put the tube fins on the core vehicle instead of on the pods. So you can see that bug is fixed. Oops, didn't want to make them longer. I wanted to move their location. Let's look at it from the base view. So this tube fin right here is not really in a good location because here's the rocket motor and it's just going to burn the heck out of that thing. So to change that, what you would do is come here to radial position and just rotate it around, and what I would do is rotate it around so that the flame from the rocket motor comes between the two fins. This probably should be 30 degrees exactly. Yeah. Click OK. And let's look at it in 3D. That looks weird, doesn't it? I like that though. I like it. That's kind of a nifty design. To make this actual to make it work though, you'd probably have to move this tube a little bit forward so that the tube has something to glue onto right here. So let's go here to this pod, edit that pod, And let's change to a side view. And we're going to move the location of the pod, and it'll just take everything and slide it forward. So let's slide it forward 1 inch. Yeah, like that. Click OK. Come on, I'm waiting for it to click off. There we go. If you want to make this screen bigger, you can also, there's a certain, on the main screen, the home screen, the view window down here, there's a maximum size it can be. And to make it bigger than that, what you have to do is detach the window from the screen. And you do that by clicking on the button here. On Macintosh, it's over here to the left. On Windows, it's on the right side. And you click on that, and it detached. And then I can just click and drag and make it big. But now it's too big. So there we go. So that's kind of what it looks like. And this rocket should be stable. Yeah, so it's even more stable. Let's take these nose cones off. So to reattach this screen right here, you just click and drag the header, and you can drag it down towards the bottom and watch the bottom of the screen, the main screen, change as I get close. It's not doing it. Should allow me to just drag and drop it. It's not letting me drag and drop it. So go up here to the edit menu and say, or the view menu, and say restore window default. And then I put it back down here. Why didn't that work? Okay, it's detached. Yeah, it's not working. See, those programmers, they messed up another thing. Anyway, let's take these other pods and delete them. Delete. Yes, that's one of them gone. Delete this one. Say yes, and that one's gone. And our rocket is still stable. So you can see, if that's as far as I can zoom out. Unless I go to 3D. I'm looking over here. Carlos says it's somebody else's turn to make a question. Yeah, I like that rocket. It's just weird. You know, I'm thinking I may have to build one just to see if it actually flies really good. I suspect it's going to, because it's got so much drag on one side of the rocket, that it doesn't fly as straight as you'd think. Kevin Cespedes writes, as a design tool, will there ever be a way in the fin plan design plotter, a way to flip the pattern in reverse to say reverse the sweep of the fin design? Ooh, that's a good question. So what he's saying is, say you got a rocket like this, and we're going to add a custom fin to the body tube. So I'll do a custom fin. Okay, it brings up the custom fin editor screen. And at first it starts with looking in the database. I'm going to cancel out of that. Kind of want to resize the screen here. So what you see in blue is a generic fin that RockSim will put on the vehicle. Let me change it to one fin. And so there is the one fin. And if you go to the plan points right here, say you swept this fin. So if I click and drag a point, and I click and drag another point, and so this is a swept fin. So let's say you wanted this fin swept forward instead of to the back. And that's what his question is there a way to flip that? And the answer right now is no. I'm just trying to think, is there an easy way to sweep it forward? So this point right here is this one, and it's 3.67666 inches from the tip point right here. Yeah, there's no quick and dirty way to do it. And what he would like to see is a button. It says just flip the fin, you know, instead of sweeping it back, let's sweep it forward. So in a sense, what we're doing is we're taking like a point here, this point here, 2.7 inches, and sweeping it forward, and then taking that one and sweeping it forward. And if you can't get the point to have it more swept forward, zoom out. See, and then I got more squares over here, and then I can click and drag. So he wanted to go from swept backwards to swept forward. I like that idea. I have to think about that, Kevin. It's kind of an interesting idea as a feature request. Okay. Okay, Space Dog asks, how do I add a new payload section to a previously designed rocket? Okay, so let's cancel out of here. Save my changes? No. Okay, so I need to open up a new rocket. So rocket designs, I'm just opening it. Doesn't matter, except it could, you know, kind of normal looking. Okay, click open. Save changes? No. Okay, so here is a rocket called the Corporal. And this one already has a payload section. I don't know if you can see it, but it's subtle. There's a darker gray here versus a lighter gray there. This darker gray is a payload tube where you can put a payload into it. So normally what we would do, let me delete this payload tube and see what happens. So hit delete and say yes. Really delete it? Okay, so it did what I wanted it to do. So it shortened the rocket and attached, now the nose cone is attached to this body tube instead of to that payload tube. So now the question is, how do I get that back? And the way you do it is, okay, that payload tube is attached to the nose cone. Let's see if this rocket here, I thought this rocket broke in half. It doesn't. It's got all these nice dividing lines on it, but it doesn't break in half. But that payload tube is going to be here to about here. But it's pretty easy, and it's basically it's just another body tube. So here's the nose cone, and then you select the nose cone and say, I'm going to add a part to that, and it's going to be a body tube. So click body tube button, and it always opens up the database. And now we got to pick a tube. This diameter of this rocket right here is 2.6299. So what I'm looking for is an outside diameter of 2.6299. And let me sort it by outside diameter. Scroll down until we get to the 2.6. 2.3, 2.5. Okay, so here is a 2.65, which is pretty close. Here's 2.67, which is pretty close. Not 2.66. So let's pick this one. We'll make it a blue tube. Blue tube is just a material like paper. In fact, blue tube technically is paper, but what it has is a vulcanized resin impregnated into the paper, so that gives the paper different material properties. So it's stiffer and more impact resistant, but it's also heavier because it has resin in addition to the paper. So I'll click OK, and when I do, it's going to put a new tube right there, which it did. And so now it's just a matter of adjusting the length of that tube. So let's make it 10 inches long. So here is our new payload tube, and it's not very big, but that's okay. It looks big enough for an altimeter. And let's make the color, like that color there, and change the 2D color to something similar so we can tell it apart, and click OK. So there's the tube. So now we have a payload tube, and the only thing that we're missing is the coupler on the back end to couple this tube to that tube. There's already a shoulder on the nose cone. So if I click on it, you can kind of sort of see what's going on. Come on. I clicked on you. Okay. Come on. There we go. If I click on this tube, this part should be hollow. Come on. There we go. So you can see there's no coupler in there, so you'd have to put a coupler into that tube. So that's that body tube that we just added, which is up this one. And we'll add a coupler to it, and that coupler needs to be a 2.66, somewhere in that vicinity. We can use that one right there, 2.56. You can see right there. And then it's just a matter of changing the location to right there, which is good. And then what you would do is put a bulkhead on it and mass objects for that. And it'd be the fastest thing to do. So then we got your complete rocket. Okay. Rick DeFossis says, could you just put a negative sign in front of the x-axis coordinates? And so Rick has gone back to that other design that had custom fins on it. And the answer, Rick, is no. It's not quite that simple because the reference point. So if I added a custom fin here. So here is this new custom fin, and before we had it swept to the rearward. So if I go to the plan points and click and drag these, I'll do it with the front point, and so then you can see what I'm talking about. So this front point right here, which is now right here, its X location is 4.9. Let's make it 5 inches just to make it a nice even number. Hit tab. So that point is referenced 5 inches back from this point right here, and then outwards 5.09 inches. So if we just make this a negative number, okay, it moved it forward. Let me undo that. Undo last. What happened? Let's make it 5 inches. And then click OK. Okay, so there's the fin. Let me delete this other fin set. Cut. Say yes. Just to get it out of the way. Cut this one. Okay, so now we have the fin set there. So, and let me make it just one fin so we can tell it apart. Because what we're going to do is we're going to create another fin, and we're going to compare the two. And let's move it to the bottom of the rocket. So let's go radial position 180 degrees. And it moves it down here to the bottom. So click OK. And let's just keep it in 2D right here. So, oops, let's go this side. Okay, so there's the fin. Now let's duplicate that fin. So we're going to copy and then paste. So it pasted it right on top of the other one. And let's change the location. Radial position 0, tab. Okay, so now let's go to the plan points. So you can see the shape here. So what we're trying to do is to match that shape. And if you just change the numbers here, so plan point number 3 is that one here, and make this a -5. And moves it there. And then this point here has a 6.77. So if you make that a negative, see it crisscrossed. So that's why it's just not a matter of simply flipping it around. Because now what we got to do is we got to make this point the front point. We got to flip this one to over here, which is that one right there, and it's 5.2. Is it 5.2? Yeah, it's 5. That's a big fin. Yeah, so if you make, so you can't have a point here on the tube that's a negative number. Like the front point of the tube, or the fin where it attaches to the tube, is always 0. And I would need to make this one negative 5.2. So I need to take this one and make it a 5.2. And then the other one is, see how complicated this is? I need, 5.2. Hit tab. See, it just reverts back to a 0. I can't quite do it. So the way then you have to do it is, okay, I got to move these points here. I need to move this one back and then take this one and move it more forward. So it's not quite easy to flip it. Yeah, it doesn't look anything nearly like that. You have to massage it around. Yeah. So it's hard. It's very hard. Even I can't do it. You know, there's some math involved, and if you do the numbers, you can flip it. But just flipping the negative sign, you can't. Okay, we got Ron James Jr. says, if I was going to 3D print a complete rocket, would it be best to change all the parts to filament material, to just use a mass, or just use a mass override for the difference in weight? The best thing would be to change the material, because then you're going to be a lot closer to the actual weight of your printed rocket than trying to use a mass override. You could, after it's all printed, then you could weigh your rocket and just use the mass override. But if you haven't printed your rocket yet and you wanted to do your simulations, then yes, make those changes to the material up front. Carlos K says, what controls when the engine block button appears? Okay, cancel. Save your changes. No, I don't care. Okay, so we have a body tube. We need to highlight that body tube. That tube right there. Click cancel. Cancel. Yes. So when we select that body tube right there, the engine block does show up. I think it might show up anytime that you have a body tube, either inside or external, it would show up. I can't think of an instance when it wouldn't show up. See, it doesn't show up inside of a coupler. It will show up on that body tube. It shows up on that body tube. Yeah. It wouldn't show up on a tube fin because that's not technically a body tube, even though it's made out of a body tube. Carlos K says, I made front swept fin alpha once. The broken fin parts were pretty easy as they the broken fin parts were pretty as they drifted down. So what he's saying is, as it went up, the fins came right off. It shouldn't have happened unless you didn't put enough glue on. That's funny though. That's all the questions that we have. And we've already gone an hour, so I guess this would be a good stopping point. But if you have questions that weren't answered, you can always go to the contact form on the Apogee website, which I showed you earlier. Anywhere on any page, there'll be a contact form link, and you can ask your question. And what I might do is save them for next week when we do these. And that way we'll have questions to answer. So I think that's going to be it for today. We are scheduled again for next Friday. I'm not planning on being anywhere, so I should be back. But if somebody wanted to guest host, we'd have to set that up, make sure that it all works. And so, yeah, contact me through the contact form if you'd like to be my guinea pig and let me watch you design rockets. Okay, so we're gonna exit this. Let me switch screens here. There we go. Let me exit this. So in 5, 4, 3, 2, 1, go out and launch something.